Sawadee my name is Bhudharhita Teinwan. So today I'll be presenting about my role in the Supersonic Wind Tunnel project. My main responsibility is working on literature review and preliminary sizing. I did some additional analysis that is not required for the project, but it's my personal interest, such as cost analysis and market analysis. So let's first start off with literature review. So why do we need a literature review? The reason why we need to make the literature review before starting working on any calculations for the project is that because in the engineering world we focuses on the phrase called standing on the shoulder of the giants, where we build on knowledge from prior knowledge that is known. So by doing literature review, we were able to understand what have been done in the world, what have been calculated, any physical relations or mathematical formula that is applicable for this project that we shall obtain for further analysis, or even some what is yet to be known, or what have they done, what is common thing that they done. This will shape our understanding of building a supersonic wind tunnel, and that will lead us to a better analysis, more straight to the point, and not wasting most time to find out different relations and reinventing the wheel. So most of the literature review that I've done is mostly focusing on the guidelines books that will give us not only the theory behind building a supersonic wind tunnel, but also a practical insight of how supersonic wind tunnel is done in reality. Okay, so let's first start off with our first book that we'll use for the literature review. It's a book called Fundamentals of Aerodynamics, written by John Anderson. This is also a book that we use as a tool to study different topics in the Aerodynamics 2 course. And this book is really well written, that it is easily understandable. It allows the reader to really understand the fundamentals in the aerodynamics world, and it also, the way it was written is easily we can easily follow the logic and the concept behind the the subject of aerodynamics itself. So in this specific project, building a supersonic wind tunnel, we will focus on chapter 10, where Anderson focuses on compressible flow through nozzles, diffusers, and wind tunnels. As you can see, that there are lots of theories behind this, and Anderson explained everything. The theory, the physical relation. He also uses the equations and proves it step by step, so that we can logically understand what's behind and how these ending equations come from. So there are three main sections for building a wind tunnel: a nozzle, test section, and diffuser. And in this chapter, he explained everything about the components of the wind tunnel. This is one of the most important equation here, where it is a relationship between the Mach number and the ratio of the area of the cross section and the throat. So as you can see, there are lots of explanation behind it, and this book will be used for theory, the way our group develop understanding about building a supersonic wind tunnel, and it will be a guideline for basics building of the wind tunnel. Okay, so for the second source of our literature review will be the book called Modern Compressible Flow with Historical Perspective. This book is also written by John Anderson, the author of the book that I've previously mentioned, The Fundamentals of Aerodynamics. But as the name of this book focuses, so it will focus more on the compressible flow itself. So The reason that I chose this book to be another source of literature review is that along with the first book of the fundamentals of aerodynamics, we will be able to understand and have a thorough understanding in the context of compressible flow, especially in the application of the supersonic wind tunnel. An example will be in this chapter that he elaborates more about the theory behind. If it's closely observed, the theory and the context itself closely resembles with the previous book, The Fundamentals of Aerodynamics, but it as again we will use together this modern compressible flow book and the fundamentals of aerodynamics book together. We will gain thorough insights towards this calculation and the theory behind before working on this project. Moving on to another source, this is a book called High-Speed Wind Tunnel Testing, written by Alan Pope and Kenneth Going. As the name says, testing, this book is more of a practical guideline for our group to construct the supersonic wind tunnel. Instead of having lots of theories and lots of deriving equations, this book instead have lots of figures and tables to explain how the high-speed wind tunnel works. As you can see from these pages, there are lots and lots of figures explaining how things actually work. So therefore, this book is how the reason why I chose is because this book will give more practical insight of building a supersonic wind tunnel. Though there are lots of theories explaining, but the theory part will be referenced from the Anderson book that I've mentioned. The key takeaway from this book is from here. There are lots of tables and figures explaining the relationships and graphs so that we can have preliminary insights of how the relationship between the Mach number and different parameters work. One of the most important figures that I would like to point out is here, figure 24. It's a figure explaining the variation of theoretical fixed geometry second third area with the Mach number, where we assume the gamma is equal to 1.4. This figure is crucial because we will further develop our diffuser geometry based on this relation. Note that the understanding behind before we use this figures or tables is already developed from reading and understanding the concept behind it from the Anderson book. So we didn't just look and point at a point and use it, but we have developed the understanding based on the theory from the Anderson book, and here in this book we use it for practical insights. Another interesting figure to point out is this figure. So this figure shows the different cases of Mach number and tunnel compression ratio, but note that this thing is already mentioned in the Anderson book, but not every case is present. Anderson book mainly focuses on the theory behind it, right? So therefore it is based on several assumptions in ideal condition, but this book as I've mentioned and emphasized, that it is focusing more on testing and practical insights. So here they provide several cases when testing in reality. So this figure will be further developed to size the pressure ratio of our supersonic wind tunnel, and so now we can have a prior sense of how it works when in a ideal condition or in a typical condition where there are presence of several these unfavorable factors. However, the thing that I found out from using this book, which is the most difficult part of using this book, is that this book is based on the imperial units. However, our analysis is based on SI units, so therefore a conversion from imperial units to SI units is required. To add on, this figure also, in determining the pressure ratio of our supersonic wind tunnel, the geometry and the boundary conditions of this project is derived from this book as well. So this book allows us to go straight to the point of where shall we build, where shall we first analyze, and how should we develop our wind tunnel. So for the last three sources of literature review that I've mentioned, they mainly focuses on the aerodynamic aspect of building a supersonic wind tunnel. But however, in building a wind tunnel, we could not omit the aspect of structural analysis. So therefore, this final report of the previous senior project is obtained in order to understand more about structural analysis in building a supersonic wind tunnel. So this is the report of our seniors Napas and Aditya, that they work on supersonic wind tunnel design and fabrication. As the name states, this also includes the fabrication process, which is not mentioned in the previous sources that I've talked about. So let's for example, here, starting off in this page, he focus on the structural analysis of building a wind tunnel. The stress analysis, here, one Mr. Stress. So by following this analysis that he has made, we will have a more thorough understanding of what structural analysis shall be made for our supersonic wind tunnel and how will it be fabricated. Here there are lots of details about how he fabricates the supersonic wind tunnel. We have a more basic understanding about milling the steel, that we, for example, if we want to have a 84 millimeters of steel, we cannot find anywhere on the market. Therefore, we need to buy 100 millimeters of steel and mill it until it reaches the point where we desire to. That's the insight that we get from this report. This report, not only as the name mentioned, the author of this report has a full development of this the wind tunnel, from aerodynamics analysis from upstream to downstream where it is built. So this report will give us the insight of how the practical aspect or the structural aspect of this supersonic wind tunnel that we are about to build is based upon. However, one point to be made from this report is that the seniors only focuses on building a nozzle and a test section, not the diffuser. As this figure shows, there's only one point where there is convergent divergent nozzle. But in this project, we need to have a diffuser as well. So therefore, this report only gave us insights of building the nozzles and the test section. Further research will needed to be made for the diffuser part. And the reason behind that they don't build the diffuser is that they don't care much about the pressure loss, which leads to the energy loss. So but in our project we do care about it, so we also need to include the diffuser as well. Here I would like to also mention about another source that is minor another minor source that we also look into it. It is called the High-Speed Wind Tunnel and Test System Design Handbook, written from Lockheed Martin. It is more of a engineering manual of how the high-speed wind tunnel is built and made for a commercial purposes. So therefore in the end we didn't use this source that much because the scale is quite different, but it is a good handbook to study and see how the wind tunnel is actually made in the world from the top company in the world. Another thing that we still need in order to build perfectly, have full insight of how a wind tunnel should be constructed, is the practical view of it. For the previous sources that I've mentioned, they focuses more on theory, diagrams, and now we want to know more about the practical aspect, like how will it look in the end, what components does the high-speed wind tunnel requires. So this is an online source from the Von Karman Institute for Fluid Dynamics, one of the most popular fluid dynamics institute. They has a picture of several supersonic wind tunnel. So when observing these sources, we have more understanding and have a clearer picture in our head how the supersonic wind tunnel will result in the end. Here they have the components of a full cycle supersonic wind tunnel. This will be the general guidelines of what to expect and how it looks in the real world.